Bionic Tibetan Antelope Robot, Unveiling the Secrets of Plateau Migration. At nearly 4,800 meters above sea level in Kekexili, a lifelike Tibetan antelope quietly joins a migrating herd. Researchers had assumed only remote observations or invasive tracking methods could reveal the mysteries of these highland elves. Today, a bionic quadruped robot has broken that barrier, embedding itself seamlessly among the animals and capturing data that eluded science for decades. Studying Tibetan antelope migration in Kekexili has long been fraught with obstacles. The average altitude exceeds 4,600 m, temperatures average -10 degrees Celsius, and terrain alternates between snow, swamp, desert, and river crossings. Vehicles alert and scatter wildlife. Scientists risk oxygen deprivation and extreme cold. Telescopic sights lack the precision to capture physiological data. These hurdles left fundamental questions unanswered. How do antelopes navigate with pinpoint accuracy? And what drives their arduous 100-kilometer spring journey? The Jiuying X30, a stealthy research companion. The Jiuying X30, developed by Hangzhou Yunshan Technology, dons simulated antelope fur to melt into the herd. From 2 kilometers away, operators guide it through varied terrain for over 10 kilometers, all while remaining undetected. Primary role: herd infiltration and data collection. Mobility: quadruped gait with 92% posture mimicry. Payload capacity: 85 kilograms. Endurance: 4 hours. Sensors: multispectral physiological monitoring. Communications: self-organizing network in unmanned zones. Key AI feats include 3,000 hours of terrain simulation training. Real-time assessment of swamp load-bearing and ice friction. Dynamic gait algorithm that deceives antelope vigilance. The Mountain Cat M20, sustaining the expedition. Complementing the Jiuying X30 is the Mountain Cat M20, a wheel-leg hybrid designed for logistics at altitude. It scales sand dunes while carrying oxygen cylinders and supplies for the research team. Primary role: transport of oxygen and equipment. Mobility: wheel-leg hybrid, 5 meters per second top speed. Operating temperature -20 degrees Celsius to 55 degrees Celsius. This synergy ensures both data collection and team welfare in conditions that once spelled near-certain failure. Kekexili's wildlife crisis began in the 1990s when poaching drove Tibetan antelopes from 200,000 to fewer than 20,000. By 2009, concerted patrols ended poaching entirely, allowing numbers to rebound past 70,000 and shifting the species from endangered to near-threatened. Despite this success, patrol teams still face wolf packs, quagmires, and -40 degrees Celsius extremes. Modern robotics now lightens that load, enabling sustainable stewardship of this fragile ecosystem. For the first time, undercover robots provide continuous, real-time physiological data with error rates far below those of remote observation or hormone assays. Multispectral sensors record breathing rates, heart rhythms, and movement patterns. A temporary communications network transmits data live over 5G from the Forbidden Zone. Undercover monitoring promises a vital sign database to decode migration triggers and navigation strategies. This marks a paradigm shift from indirect inference to direct measurement in wildlife behavior studies. Building on its debut success, Yunshan Technology plans to tailor future models for high plateau demands. Anti-theft geofencing and tamper alerts. Thermal imaging trackers to operate in snowstorms. Extended low-temperature endurance beyond 4 hours. Adaptive camouflage that responds to seasonal vegetation changes. These innovations foreshadow a new era where technology and conservation advance hand in hand. In a landscape once deemed off-limits to humans, robotics has become both guardian and chronicler of one of Earth's most enigmatic migrations. The Bionic Antelope mission redefines how we study, and ultimately protect, fragile ecosystems, proving that respect for nature can take the shape of steel, sensors, and synthetic fur.